Cool. Hey, my name is Garen Torikian, and today I want to talk to you about API documentation. And this slot is a bit rough because it's right before lunch, which is one of my 3 favorite times in the day. But I'm going to try to do my best to keep this engaging. This title is a bit bombastic, but I really want to emphasize the finally and the trustworthy parts of the title. But before I get into the details, I want to introduce myself real quick. I'm an engineer working at github.com, the website. I work on the API that supports the GitHub platform. I've built loads of open source documentation tooling, some of which is on this slide. But before that, I was a technical writer. I actually started the documentation team at GitHub a little over 5 years ago. And I'd been writing technical documentation for nearly a decade. And the truth is I love writing, and I kind of miss doing it as part of my full-time job. And I'm excited every time I get to describe some technical concept using words. And my move into full-time programming is kind of a new thing. It's only been about 2 years old since I decided to move from writing into coding. And what I realized was that after I became an engineer, I was still interested in the same types of problems that I was interested in when I was doing documentation. And this is going to be a controversial slide. I know, but I like to tell people that it's easy to write documentation. Anyone can write it. You may not be able to write it well, but you can write it. The hard part of writing is the maintaining, to make sure that the documentation stays accurate and true as the software evolves. And part of the reason I wanted to move from documentation and into engineering was to focus on the keeping accurate documentation part easier. I reasoned that if I could concentrate on the engineering problems, in some way I could help mitigate some of the frustrations that I had experienced as a writer. And basically what I realized when I took a step back from writing was that I have, and I always have been, obsessed with how we write, and not just which word is the mot juste, but also the processes and the software that we use to do our documentation, and eventually even how those docs are consumed. And this is something that affects both engineers and technical writers. Engineers who aren't writers don't know how to provide useful documentation, and writers who aren't engineers sometimes aren't given the best tools to do their work. So I want to talk about how API docs are written, what the history of that process has been as far as I've seen it. I want to talk about why it's traditionally been untrustworthy, and more importantly, I want to talk about the ways in which people are thinking of redesigning these technical systems. I want to look at where we were, where we've been, and where we're going. But just so that we all have a shared understanding of what I'm talking about, I have to quickly define what I mean by API and documentation. So let's pretend this blob here is a bank. I can put up a little label there that says bank. You can tell it's a bank because it has columns and looks very bureaucratic. And let's say you want to take money out of the bank. It's a Saturday. You have a lot of time to waste. For some reason, you don't want to go to the ATM. So you decide to go inside and stand in line. And what happens when you get there? When you get to the front of the line, the teller doesn't just hand you the keys and say, all right, your money's kept in the back left of the vault there. Good luck. Just take what you need. In reality, it works a bit more like this. You approach the bank and ask them for some money. You fill out a form. You give your account number. You give your signature. You put down how much money you want to take out. And then you hand it to the teller. The teller, acting as the bank, goes to the vault, gets the money, and then the money comes back to you through the bank. And that's pretty much your flow for how you can get money from a bank circa 1996. But an API isn't very much different from that scenario. The user, the person sitting at a computer somewhere, makes a request for some data. And that request could be made to a program that's running on your computer, or it could be made to some external website like GitHub or Google Maps, Wikipedia, whatever. And the server goes and fetches that data for you and then hands it back to you. So the API here is the layer that facilitates that ask portion of the flow. It's like the gatekeeper between the user and the data. And these kinds of systems are becoming more and more common. The more stuff we put online, the more people realize that they want to fetch that stuff and they want to do things with all that public data. And rather than companies determining what you should and shouldn't have access to, and instead of just giving you access to everything, an API determines how you can get at information that's stored somewhere else in a safe and sanctioned way. Essentially, it's like a contract between you and your data. The other part of preliminary information is what I mean when I talk about documentation. Not all documentation is written the same, obviously, and I'm a little old school, but the way I learned it was that there were essentially three main types. There's reference documentation, so these are defining the words or phrases that are unique to your software. When describing an API, these are the functions or methods that you would need to call to get access to your data. There's conceptual documentation, which can describe a whole technical system, what it's used for, what it does. These might be, for example, explaining how Git works or how photos are uploaded and stored online. And there's procedural information, which is usually some kind of ordered list explaining how to accomplish something in a series of steps. So this could be a step-by-step guide to opening a pull request or instructions on how to change your password. So of the three choices today, when I'm talking specifically about API documentation, I'm really only going to be concentrating on the first type, reference documentation. So you have a server sitting somewhere, there's some information you want to collect, and you want to know how you can make that request to get that information. For reference doc specifically, again, these are the functions calls that are available to you, what arguments they take, the errors that are returned to you, and so on. It's like a reference sheet, a dictionary that lets you speak the language that the server is going to understand. And when it comes to APIs, reference documentation is the most pertinent form, period. I'm going to go back to that bank analogy, and I'm going to keep going back to it. So if you don't find and fill the right forms, you won't be able to do anything with the money that's sitting in the vault on the other side. A server sitting online somewhere is the same thing. It's a mysterious black box. And if you don't know how to talk to it, you're not going to be able to get anything from it. And if, as a writer, you don't adequately describe how someone is going to interface with your system, you run the risk of them not using your system at all. So accurate and consistent reference docs for APIs is super important. Okay, so I've detailed the technical system I'm talking about and the kind of documentation I'm referring to. So the theme of this talk is finally trustworthy API documentation and how it can be produced. But in order to explain how we are where we are, we're going to basically travel through the years, and each segment is going to build on top of each other and culminate towards an understanding of how API documentation has been produced and how current systems are changing towards a trend of more trustworthiness. So it's time for all of us to close our eyes and step in our mental time machine. We're going to go back to 2006. It might have been a better time, it might have been a worse time. We can all agree it was some point in time. And for me, this was a pretty good year. I got my first job doing technical documentation. I didn't plan it. I didn't even know that technical writing was a job. And what I experienced in 2006 was this notion of documentation next to the code. And by show of hands, does anyone know what this is? Not a single hand. Wow. This is documentation. This is a book that was published in 2006. I actually wrote parts of this. And I want you to keep this as a visual kind of memento throughout the course of this talk. So this particular one is for some architectural software. It's 1,200 pages long. I'm not really that old, but for my first job, I would write documentation on the computer. We'd send it out to an editor and a publisher, and then a few months later, you'd get this. And it would come with you, basically, when you bought the software. Chuck it on the floor for now. So how did a book like this get made? At the time, we used this I thought it was a pretty amazing tool called DakaMatic, which the name alone is magnificent. And I realized as I was putting together this talk that this company is based in Berlin, so if you're in the room, hello, I definitely used this for the first 2 years of my job life. And the screenshot's from the latest release, and I don't know how the software works now, but in 2006, what DakaMatic did was pretty simple. It would scan all the files in your project that contained your source code. And as a writer, I'd go through each file one by one, and I'd write documentation based on my understanding of the source. Red boxes next to a name meant that there was missing documentation, and green boxes meant that there was at least some documentation. And the API I was documenting was a set of methods that a user could call to automate drawing shapes and adding shading and other architecture-y things. And you can see some of the stuff I needed to write about is pretty common to nearly every API. I had to provide a summary of the function, I had to list out its parameters, what their types were, what they did, and so on. And in theory, this was a good idea. The engineers had all the files split up, and I could just, go into a Zen mode and go down each file and write some content describing the system. But as a humble technical writer, I was forbidden from changing the source code, which meant that although I could see all of the source, I had to keep all my documentation in a separate folder stored in a completely separate space. So this caused a number of problems. The first problem was that documentation was prone to missing updates. As a writer, I had very little insight into how the engineers were making their changes, which means I could spend a week documenting some part of the API, rescan the files, and discover that some arguments had changed, some method name had been renamed, or something I had documented had disappeared completely. And because I was working on my own little silo, I also had to send the documentation that I had written back to the engineering team for approval. So they would work on the code, I would document it, I would send what I wrote back to them and ask if I'd understood everything. At which point they would invariably always say something like, "Oh yeah, we changed that part of the system, sorry." And of course, because of all that, there was a much slower pace of documentation that I could produce. So working at a tech company, I don't need to tell anybody, is very manic. Sometimes there's periods of lulls, and sometimes you're forced to speed up and play catch up as deadlines approach. Which means, of course, that the documentation written at the beginning of a project is typically clearer and more accurate than the stuff you write towards the end of the cycle, which is sloppier and not carefully reviewed. So that was then. Let's jump forward another 6 years. I had moved around between different jobs, but by and large, the process I experienced was largely the same. Writers weren't allowed to access the same code and systems that the engineers were using. So very often, the things that were being built were not being described as accurately as they could be. So I took a role in 2012 as a tech writer at a startup working on their APIs. And I really wanted to write documentation in better ways than I had been exposed to. So that's when I first experienced working with documentation from the code. And I'm going to take a brief tangent for a moment here. I swear it's all going to come together. I love languages, human languages. I love learning new ones. I love hearing them spoken. I love the words. I love the slang. I love word games. I love how they express a person's culture. So let's talk about language for a little bit. Let's say you have this sentence in English. The book is blue. If you look at that and you know English, you can break it down grammatically into various parts. There's an article, there's a noun, there's a verb, there's an adjective. You know that in English, this is describing a single item, the quality of it, and its state. Let's look at the same sentence in Spanish. El libro es azul. The words are completely different, but the concepts are the exact same. There's an article, there's a noun, there's a verb, there's an adjective. If you speak English and don't speak Spanish or vice versa, you can still understand the concepts, even if they're in a different language. If I told you that libro meant book, you would immediately know that it was a noun, what it looked like, what you did with it, etc. You're able to parse the meaning of the sentence into different parts. So the thing is, programming languages behave the same way. You might hear someone talk about how they prefer to write their code in Ruby or in Python or in JavaScript, whatever. But the point is the underlying concepts are fundamentally the same. They all abide by a grammar that is shared between them. They just use different words to get their point across. They all have arguments, they all have methods, they all have comments. And because they have a grammar like this, that means they can be parsed and analyzed and represented in different ways. So in the slide before, I'd highlighted the different parts of the sentences, article, noun, verb, adjective. And for a programmer, when they're writing code in their editor, the words are represented the same way. When they're writing code, the text that they look at doesn't look like this. It looks like this. Color delineates each part of the program. In yellow, you have comments, and purple is function names, and blue is a string, and so on. So here's where it starts to get interesting, and here's where I'm getting to my point. Before, as a writer, I would have had to keep a separate document that kept track of each method and arguments and create documentation next to the code that was prone to go out of sync. But once we start to consider that we can extract the comment portion of the code out, we can start to look at the two pieces as not independent entities, but as parts that can work together. So we can generate documentation straight off of the comments. When the documentation is next to the code, there's no need to keep track of whether or not the method is going to change, in theory. There's less of a chance that the documentation is inaccurate. At a glance, one hopes that you ought to be able to verify if the documentation is correct or not. Everything is kept in the same place, but there's still the potential for problems. What happens if the programmer changes this method? Now it no longer takes a single argument name, and instead it takes two arguments, a first name and a last name. And all of the tests the programmer has written for the code would pass, and if we only generated our documentation from the comments, this would also pass through unnoticed. A good documentation tool will refuse to build the documentation if it notices a discrepancy. So this way a writer can be certain that any changes to the code is always reflected in the documentation. But that requires a pretty intelligent documentation generating tool. So there are hundreds of different languages. And even though you might know about grammar rules, you might not be as familiar with how different languages are parsed. But even still, as a human, it's easy to understand that book and libro both mean the same thing. They're both nouns. But depending on what language your code is written in, the documentation tool will need to know the specifics of each grammar. On this slide, we're documenting the same method written in 3 different ways in 3 different programming languages. And as a human, it's easy to reason that the yellowish blob is the comment style for each of these languages. And while a documentation tool or several tools could be built to parse each of these languages, it's most likely going to parse each language in a different way. It's not reasonable to have a single tool that's going to turn all the comments for every kind of API written into documentation for every language. So while this idea of keeping your codes and your documentation closer together is taking us closer to accuracy, the reliability of documenting things the same way continues to change as you move between different programming languages. You still need to be vigilant to ensure that the comments are accurate, for lack of a better word. But let's keep building on that idea that code and docs are 2 fragments representing the same idea. So we're coming up now to present day, and this is the trustworthy portion of this talk. The documentation isn't coming from the code, the documentation is the code. About 2 years ago, the fine folks at Facebook.com announced GraphQL, which they had been using internally for about 5 years at that point to build their APIs and for their websites and their mobile apps. And the important distinction is that GraphQL isn't really a programming language. It's more of a specification for how to model data and how to make requests to get that data. GraphQL is a way in which you can describe an API. It's a new way of modeling your existing data, and it exists independently of the way it's implemented, which means that if you write an API using GraphQL, it can be implemented the same way regardless of the programming language. So let's go back to the bank analogy. GraphQL would be like a specification for that withdrawal slip that you would need to write, that you hand to the teller. It specifies the same properties, the same fields, the same inputs, which means that for every bank you go to, no matter what the bank is, the form looks the exact same. So as a user, it lowers the cognitive barrier if you decide to switch banks or servers and you need to get money or data. And a GraphQL schema is fully introspective, which means that every part of the schema knows about every other part. Which means that a GraphQL schema can parse itself, which I'm going to get more into in a little bit. But the most interesting aspect for me and for this conference is that GraphQL has a very documentation-centric approach. So on this slide, there's an example of a GraphQL schema. This is a blueprint for how someone can communicate with an API. And at the surface, it's building on a lot of the concepts that I've mentioned. Here, we're describing a restaurant. Each separate line here is a field, and each field has a clearly marked type and a comment. This schema can be parsed, and because it's language independent, it doesn't suffer from the same problems that I mentioned earlier. There's no such thing as a GraphQL schema for Python, and a schema for JavaScript, and a schema for Ruby. There's just this one schema specification. And it's not just a blueprint for how users can interact with the API. It also self-documents. If the schema changes, the documentation changes too. And here is the most frightening portion of the talk. There's going to be a live demo because there's no better way to explain how GraphQL works. So hopefully, yes, perfect. Perfect, perfect. except I can't see. Give me one sec. So my friend David and I, we built this website, this very real fake website called Whelp. Whelp.reviews. It's an actual website. You can actually go to it. And what we do is actually something that's very original and unique. We have a database of restaurants, and you can basically query this database and get information about its names, its price points, other attributes, and other features. And so, here's the real-life schema that's powering Whelp.reviews. This is kind of a longer version of the slide that I just mentioned. And unfortunately, the focus of this talk is more about documentation as it pertains to GraphQL. So I don't really have a lot of time to talk about GraphQL or why it's beneficial, but if you want to come talk to me after this presentation, by all means, I'd be more than happy to discuss it. And you can see basically from the schema, you can generate documentation. These are all the exact same properties that were present in that schema before. There's nothing too wild or crazy here. But the interesting thing about GraphQL is that it comes with this tool called GraphIQL. And this isn't anything custom. This is just part of the specification. And what you can do is basically, as you as a user are trying to craft your query, the IDE will start to autocomplete for you. So I happen to know I can get restaurants off of the root kind of node here. And the comments that are present in that dropdown are the exact same comments that are present in the schema. And while I might not know every field that's available off of a restaurant, I can start to guess, okay, there's names, what the owners decided to call this place. There's price, how cheap or expensive, what are some other things? Has bike parking, I believe is one. Has TV, why not? And you can run that and you can get that, as a response back. This, on the left here is your API basically, and that's the data that you can get back from it. So even if you don't know as well, like I do since I built the dang thing, what fields are available, it also comes with its own inline kind of documentation explorer. So I know that there's a field for user, and I can drill into that and see what fields are available to the user and click around and learn more about those properties. Here's where it gets interesting. So there's a field on here called current user. Its documentation is the authenticated user. And for whatever reason, I don't like that name. If I go to the schema, current user, and I rename it to this, maybe I add some documentation, changes, I save that, I come back here, I reload, and current user no longer exists, but me now does. And me is automatically, has all the drop-down autocomplete functionality that you would expect. But what's the problem here, right? Like, we used to have this field, and now we don't have this field anymore. And since the documentation is the code, you can basically test your documentation. You can test your code. Over here, I've written a really quick sample test of what that might look like, which just runs a diff between what the schema was and what it is. And it notices that current user is no longer there, which is problematic if you were a third party somewhere and you were building a client and you were trying to get the current user field. All of a sudden, from the engineering perspective, I've removed that option for you, which is not good. The other interesting thing, if we look at this tip documentation, you'll see that there's documentation missing for some of these fields. So for whatever reason, someone hasn't filled out the comments for that property. As well, I can write a test to ensure that every part of the API is documented. And again, it doesn't mean my documentation is necessarily written well, but at least I can know from an engineering perspective, documentation is missing. And I can call on a writer, we can hash things out and figure out how to make this a better experience for the user. Switch back to slides real quick. Fantastic that worked. So why is this new way of writing APIs good for writers? It allows them to concentrate on the conceptual and procedural parts of the system, the parts that are a little more opaque, that maybe require a little more hand-holding. it's good for engineers because it forces them to think about how what they're building and what they're changing is going to affect, how it's going to affect end users. And it's great for users because rather than hope and guess that the reference documentation is accurate, they can be certain of it. The tools that are provided to the user via GraphQL are just make that a certainty. So we're really only just getting started with GraphQL. Facebook open sourced it in 2015. GitHub's really only adopted it in 2016. But I'm pretty excited about what the future of GraphQL documentation holds. And it really is mind-boggling to me to think how, in a span of 10 years, like you basically went from publishing a book, which is now a doorstop, to being able to have this access to all these online kind of intelligence and autocomplete stuff. So I'm really looking forward to how GraphQL documentation tooling improves over the next couple of years. And that's it for me. The whelp.reviews website is open source if you want to go check it out, and I'm at GJ Torikian almost everywhere on the web, and I'll be posting these slides on SpeakerDeck or what have you. Thank you.